Okay, this is a quick tutorial for the Pyrosim software. So let's start. This just covers the basics so that you can edit different scenarios. So I'm gonna start from scratch. First thing, the actual software files are these PSM files. I don't know what the .ps is or these other files. I don't know. I'm assuming that you already installed the software and all that stuff, so I'm gonna edit only this one file. Double click on it. I have a 30-day free license. Just hit OK on there. Okay, so this is my actual this is the model that is referencing the FDS stuff. You can just click on it. Alright, so the first parameter, first thing I'm going to talk about is the mesh. The mesh, which is, you know what the mesh is. The mesh size can be defined here. Double click on it. This is the mesh that you either already created or if you wanna create a new mesh, just hit here, new. This one is already created for all these models for this project. So you can tell that this mesh is extremely big. You'll be more accurate, but it'll take more time to calculate. 67,000 cells. If you want to reduce that time, just decrease by the same percentage each of these cells. So I have it as a uniform mesh. It's just recommended. So you can see here the ratio is 1, 1, and 1.01, so it's uniform. If you want to alter and make it either smaller or bigger, just make sure that you keep the ratio within 1. So that's that. I'm gonna leave it like that. Next thing I'm gonna talk about, it's there are different so all these walls, baffles, that ceiling, this panel, all of these are surfaces that were created on this model or imported from CAD. I don't know. So each of those surfaces are gonna have properties. So let's select this wall. As you can see, all of those obstructions or surfaces, they call them obstructions too. So all these surfaces are gonna be here under model, under the model tab. This one, for example, is the vertical baffle. So vertical baffle. You wanted to see what is the angle baffle. Just click on it and you see how I highlighted it. So now let's say that I want to see what are the characteristics of this one. I go here, double click. So general, the name, activation always on, or you can create a different parameter. Relative to object, I seen that it's always in 0. All this stuff are just standard or default, and the boundary box, that's the dimensions of that stuff. In the geometry tab, that's where you can alter this what is that, coordinates, so you can create the box or modify it as you want. Okay, surfaces. This is the tab where you insert, where you edit whatever you want it to be. So this one, if you want just to do a wall or something that it doesn't have any effect or any properties, just put it as inert. No, so here's this thing. Before you see all this drop down menu, each of these options come from here, surfaces. I just hit cancel here. So just take a look at these ones: adiabatic, exhaust, fire 150. Anyways, those were created here first as a surface. Every surface that you create here, you would be able to see it here on this drop down menu, and you can select to that surface to give it a specific property that you created for this surface. onto that wall. So let's just hit cancel. This is gonna be the inert. So somebody either, I don't know if it's default to the software or somebody created already. I have it here, inert. Here you see the same list here. Inert, you can create a new one here by clicking that. If you want to create a new type of fire, this is where you click new surface, then I would say like fire whatever, and then you just create it. And if you want to take it like from a template so it's easier, I would say fire X, and I wanted to use the template for this one that I already created, fire 201 kilowatts. You would take all the same properties and you just have to alter the ones that you want. Anyways, I'm not gonna create anymore. So let's go back to the inert here. As you can see, I mean, it's just that. It seems like it's just default because it doesn't let me do anything. If I wanted to create, so here you see that this one is crossed out. This one is crossed out because I right clicked on it. I put enable, then it's good. Disable, then it crossed it out. So if you don't need stuff in this on this model, then just disenable it to make things run faster. For example, so these surfaces, that's where you give the properties to any surface. This is where you create your fires. For example, here you have your hot plate. I disable it because on this example, this piece is not just a hot plate, it's an actual fire that I'm going to simulate. That's why I crossed it out. This is the fire size that I want for this on this model. Let's go over these properties. This one I created it here. Actually, I'm gonna create a new one. Fire test, just to show you. I want to create it from a template, which is 201. Just hit OK. It creates it. Fire test. Okay, so here, if you want it to be a fire, you're gonna put a burner. If you wanted to put just a heater or a hot plate that is not an actual fire, just put here heater or cooler. And then, well, you have the options to supply, exhaust, air leak. I haven't messed with those. So we're gonna put that as a burner. By doing that, it gives me the option to put a heat release rate per unit area. So this number, you should have it already from, well, you should have it. In my case, I already calculated it. So for the fire, let's see real quick. Anyways, you should have that number. So just click on it. Let's just click 2000 in here, just for the sake of showing you how to do it. Mass loss rate, you could give it a mass loss rate if you know more details, but if not, it seems like it doesn't really ask for it. Ramp up time, I'm just leaving it as a default. It could be a T-square fire. In this case, I think we're just gonna leave it in default because this is a fire that it develops just right away. It's not gonna develop over time like a couch or any other stuff like that. It wouldn't be a T-square fire. It would be just a flat temperature over time. Well, not temperature. Anyways, not a T-square fire. Extinguishing coefficient, I don't know how to mess with that. I'll just like it's default. I don't even know where to get that number right now. The thermal, I have it in default. You can mess here with the surface temperature that is under the thermal boundary conditions. I don't think that affects much. You can give it an emissivity here. One is for a black body. Geometry, you don't need to do that geometry because it's a surface. So the geometry, you mess with geometries when you create here stuff under the model, right? Since this is just a surface, then you don't give it any. And I don't mess with any of that advanced. That's it. So that's how I created my fire. So this fire is gonna be a 2000. It's gonna have a heat release rate per unit area of 2000. I hit OK, and that's it. let's see, where is it? Fire test. If I wanted to, so this is my fire. If I wanted to have this fire to have the properties of the one that I just created, I go here. I'm gonna go over this later, but so I would just here double click on it. The ID, that's just the ID of that piece of box that is gonna represent my fire. Model always on. Then as you go to geometry, as this, well, geometry is the geometry of the piece. No, here the surface. Maximum Z. I just realized that I should be using single rather than multiple, because multiple, I'm telling it that minimum height it's inert, and at the maximum height it's gonna have this heat. I think it should be single. I'm not so sure about that one. You can mess with that one and see how it changes the simulation. So you choose from the surface that you created or you already had. In this case, let's do fire test. Okay, and there you go. So that fire is gonna have the characteristics that you created in here, and that's it. So now here, this 0.126, I relabeled that one. So that's gonna be the area of, like, the area of that box that in reality is representing this circle where I have my heptane for in this example. What else you should know? So on each different scenario, so this one represents the area for a fire that it's 201 kilowatts. For the scenario where you have only a 55 kilowatt fire, this should be smaller, right? Because the area it's smaller. So in that case, you would have, I don't show it here, but in the other model, you will see that there's already this box is already created. So let's say that is this one. I enable the object, enable one additional object, yes, and I just disable this one just for the sake of, don't delete it, just disable it. If you do that, just make sure that if you wanted to run this smaller object with the same characteristics here, then just make sure that you select it, you go to a surface, and you give it the right, again, I don't know if it should be in multiple or single. You select the right surface, fire test, boom, and then you just hit OK, and then that would have that. I'm gonna switch it back to what it was. This one was what? Doesn't even matter. Yeah, it was this one. So again, just try to run different simulations, having it as a single, as multiple. I think it should be actually single. All the model from the mechanical engineer had all those surfaces as multiple, but I don't think that's true now that I think about it, because what I'm saying is that at the minimum Z of what? At the minimum Z of this box, I guess it's inert, and at the maximum Z, so at the top of this box, that's where it's gonna be the burner, the fire. So for that reason, so I'm saying that on this height nothing happens, nothing is burning, which I don't think it's true, because the fire actually starts from the very bottom of it. And I guess this could simulate the depth of the liquid. I guess you can leave it like that. Anyways, but you understood the point here. Model, that's the whole thing. For example, if you wanted to see the exhaust outlet, you can see that is that little thing. If you wanted to see the properties, again, double click on it. Surface type, you select exhaust, which just remember is the you created here, and on this under this exhaust is where, let's just hit cancel, is where you gave it the parameters. So surface type is not a burner, it's an exhaust, and then you gave it the specific velocity and all the parameters for that exhaust. What else do you need to know? I'm gonna pause it to think about it. No, I can't. Okay, if you wanted to create a sprinkler, if you wanted to put a sprinkler on the model, it's simple. Just go here to devices, new sprinkler, give it the name you want, freeze output never. It's the spray model. You can just leave it commercial spray, and then you can edit that actually if you want. You can create here your new patterns. I haven't figured out how to give it a right pattern so that it works fine, so I'll just go with that. Here you can do the discharge rate either by this number specify, or you can give it a minimum pressure and the K factor, and you can do several sprinklers. I haven't messed with that yet. So there says okay, and now you want to, now the temperature of the sprinkler, you edit it here. You can also select it from that. I just get that and edit it. Here's where you can change the properties. So initial temperature is ambient temperature, which should be actually 22 degrees for for this example, for this project. Activation temperature, whatever it is you want it to be, depending whether it's ordinary, intermediate, or high temperature. Response time index, C factor, you just leave that in 0, and then just hit OK, apply, and just get out of it. That's how you create it. It's very simple. Hit OK. As you see here on this tab, it created the sprinkler under the devices tab. Now, why don't I see anything here? Because actually I set it that to put it in the 0, 0, 0 coordinate. So if I want to change that, I double click on it here, location, and here you just figure out where you want it to go. I just do it real quick just to show you. So as the location, and then if you want it to be upright versus pendant, then you mess with the Z. Z, it's -1, which is pointing down. If it was Z positive, it would be an upright. If you want it to be a sidewall, then you mess with the, what is it, with the Y, and just put it -1, and it will be, well, actually I'm the X, well, depending on what phase you have it. So hit OK, you see, you just moved it. I just put a random number, so that's why. That's my sprinkler. When I calc my stuff, that sprinkler is going to already have an effect on the fire and all that stuff, because this sprinkler has already all the parameters so that it activates. Alright, another thing to know, it's let's say you want to run the simulation for 60 seconds rather than 12, or if you want to change the simulation time, go to analysis, simulation parameters. There you go. Start time 0, end time. Here's what you give it. If you want it to be 60 seconds, no, just do 60 seconds. Okay. I haven't messed with any of this stuff. And I'm not gonna do it on this video either. Okay. What else? Well, here, reactions. I'm assuming here's where you create your type of fluid that I don't even know what, heptane, fire suppression. I haven't messed with that yet. It was already there in the model, so I just left it there alone. and it seems like all this stuff were taken from the NIST, from the NRC. What is it called? From the approved Excel sheet for NIST. Let's see what else. Okay, let's go to the 2D slices. The 2D slice is where you are going to. It's just the plane where you want to see the what's happening. Let's click plus. All these are different planes. This one is for temperature. This one is for velocity. That is created by the mechanical engineer, I'm assuming. I only created temperature ones. So if you wanted to know your temperature at the sprinkler level, then I just create a new one. Double click on an existing. If you want to create a new one, just easy as it. Just double click on an existing one, and then here you just create a new one. If you want it in the Z plane or the Y plane, anyways, you get it. So this one at the whatever height you want it to be. Let's say that is 0. Anyways 54. On here you give it the parameter type you want it to be, temperature, velocity, anyways. Temperature, use vector, no. Cell center, no. That's it, and you just put OK, and there you go, you just created it. It's just that simple. I'm gonna delete it because I just created random numbers there. So this is the height of the temperature of the sprinkler. If you wanted to, let's see if we have one all the way up there. I have not created. Oh yeah, well this one was already there to see the temperature at the exhaust. I think this is a good plane. This is a good height so that it doesn't, when you show the graphic and I show you, I won't run it, but when you simulate it, it won't show you the temperature in this whole area if you do it all the way up to the top. If you do it just a little lower, it's gonna give you the temperature here, because on this area, well, it's within that plate, so it won't calculate it. Up to you. The previous simulation that I did, I put this layer like all the way up to the top, and that's why you can see the whole thing. But if I was going to do it again, I would just do it a little lower so that it only does it in this section and not on that as well. Just the less information. If we show the only information we're looking for, it's just the best, I think. What else? I haven't messed with any of that. Here the units, whether you wanted English units or American units, American or the rest of the world units. Metric and American, there you go. Oh yeah, these are instructions and stuff. Anyways, that's it. Let's see what else. Okay, let's say I already have my fire. I already have the planes at which I want to see the temperatures. Wait. Okay, there's one created here. On this case is because the air is coming through this way, down through those holes, back here and up through the exhaust, so that's why I guess it's good to see what temperature we have in here. But anyways, once you have all your surfaces, your fire established, your sprinkler if you need one, your planes, then it's time to simulate it. One thing that helps to figure out the height of the sprinkler is you can select this one, for example, double click on it just to see what coordinates it has. Geometry. So the height is box properties. Yeah, I guess it's 0.667. So you want to put the sprinkler just 10 centimeters below that, then it will be 0.57. Anyways, that's just a good reference to see at what height you want it to be. To run it, you go here, just do run parallel. I'm not sure what's the difference between run FDS and run FDS parallel, but in the example that I saw, they use run parallel. I haven't had time to figure out, but just go with this. It already has the files. Yes, because I had already run it yesterday. I do want to overwrite all that stuff, so I say continue, and it starts. So this mesh, while it runs, you can actually keep making modifications. And if you hold on, so this mesh is huge, 67,000 cells, and I wanted it to do it for 60 seconds. So that thing is gonna take forever. Here, double click here. It's telling me that time remaining is estimated at 54 minutes to remaining, and it changes. You see, it increases as it calculates more and it realizes that it needs more data. I recommend, if you don't need all these planes, then just deactivate the ones that you don't want to see, like all this velocity stuff, and only leave here the ones that you want to see. I believe that reduces the time of simulation, because look, time remaining, it went already to 2 hours, so that's just a little excessive. You can, here has calculated only up to 0.88 seconds. You can start seeing the results. Just click. Oops, it's not double click, it's just one click. Click there. Look, that's my sprinkler right there. Oop. Anyways, you see, hit here, play, and I guess since it hasn't calculated, it's not even 1 second, because at the time when I told it to show the results, it wasn't even 1 second. Now it's 1.24. So I should be able to see. Let's delete that one. Show results. Play. Yeah, so it's really like it can't even start yet, because there's not enough data. But I'll explain you how you can see all your stuff in here. FDS results, 2D slices, right? Because that's where you created your planes. Temperature are the ones that you are interested on, and these are the ones that you created. So this one, so if you want to see one of them, just double click on it and it will show. You see, let's say we wanted this one, or this one rather. There you go. If you only want to see one of them, then you see the ones that are on are in black, in bold. If you just want to see one, double click on it to turn it off. To change the scale of this temperature, click once, double click on it, and then you can see the parameters. Percentile rounded, you just put custom. Minimum value, you can put 22 since this the ambient temperature. The maximum value, whatever you want. That's something that makes sense, just to have an accurate scale, a scale that actually helps. I just hit, that's the only thing I hit. Just apply, okay. You see, change the scale, and now at any given, there you go. It has only calculated 1.6 seconds. That's why. So here you can see. Oh, another thing. you see the size of this black band here? That's the range of temperature that is gonna show here in black. So if you wanted to change that range to be bigger, you can scroll up or down actually. You see how it changes? Or you can just double click on it and you can edit it here. This is where I change the scale, and this is where I change the range of that black. So you can do it, let's do whatever, 250, and the minimum is gonna be 22. Look how it's gonna change the black. One. Highlight width. I don't know, didn't work, but it's just easy. You can just scroll up and down, and that changes the range. So I think just to make it a little easier to show the results, the bigger the band, the better, so that we can show that there's the area that is under this parameter and this range of temperature is bigger. It just shows graphically better the results, I think. If you wanted to choose, anyways, you get that point. You can play with that. And that's pretty much it. If you wanted to see so if you wanted to see the activation of this sprinkler, like the water, when it activates and all that stuff, you gotta go to particles and water. So if you want to see it, remember, anything you want to see here in the result, this is a different view, separate view. You see I have two different files here. This one has the, I don't know, like 3 bars at the bottom right corner that shows that is the result, and this one is the actual model. So particles, water, okay, let's go back to the results. Go to particles. Since you do want to see the activation on the sprinkler, double click on it. There you go, it's in bold. Now you will see it when it activates. It has calculated so far 2.61 seconds. And in my results, like this one is supposed to be alive. This is my result window. So you can keep it open if you want to mess with it. If not, I would just close it. That might allow it to calculate things faster. Repeat if you want to just keep the cycle. Here you control the speed of, well, the result. You see, super slow, or I want to see things faster, 4 times it. You get it. Or you can do it manual. And when you do it manual, you also see the change. So that helps when you're trying to find the maximum temperature or the temperature that you want to show. And that's it. When I want to show my results, I don't do it like that because it just takes a lot of space. So what I do, I hit the middle one here and I just bring it over closer to the scale and adjust it however you want it, so that when I do the snapshot, it's, it just takes less space and you can show it bigger in a report or whatever if you want. That's it. Once you're done, just hit save and it'll save automatically. Here you can change it, different types of showing the results. I haven't really messed with it. I just leave it in realistic, period. You can close. So remember, this window is my results window. I can close it. Say changes to the current result visualization. Just because I made changes to the scale and all that stuff, I'm gonna say no, whatever. You can still close it, but the simulation won't stop because this is the simulation window. So if you wanted to see it again, you can just hit show results again, and it'll open it up. And you will have to go to slices, 2D slices, temperature, This is whatever. Double click, turn it on, and then remember, change your scale and all that stuff. I'm just gonna close it. If you, I believe this works good to show the results. See the results at like early within the calculation. Like if it's a calc that is gonna take almost 4 hours to run, just go to, just open it up when you have when you're within a few minutes, just to make sure that it's running or that it's kind of showing what you wanted to show. That's why it's useful, rather than just wait 4 hours and then go to a result and realize that it's something that you were not looking for. I'm gonna stop it right there because I'm not interested in running the simulation. So you hit stop, it'll stop it at there. If you want, there you go, it'll immediately launch the smoke view window. This is not really smoke view, but it's the equivalent. Actually, it is a smoke view file, SMV. Okay, I just get out of that. I'm not gonna save this thing because I did a bunch of stuff just to show you. That's really all it is. Analysis, output, devices. Okay. Now, every time that you run a calculation, the software is gonna create a folder automatically, and in that folder is where all those results are gonna be stored. So in this case, the simulation that I was running was this one, LFFH, which is laminar something hood with a fire of 201 kilowatts, and I just put those initials so that I realized that that is a different file from the one that the mechanical engineer supplied. And you see, it just creates the same folder with the same name, and here is what it put. Oops, it was this one. And here is what it gives you, store all those results. This is the smoke view file. You can actually see it again, like open it up. You can straight open it up like that and see it again. A bunch of other files that I don't know, just results. It does give you Excel sheets that gives you data. This is heat release rate, this is linear, whatever that is, device input, CPU. I know that if you want a graph temperature versus time, you have to set it up first you have to tell the program to give you that graph, otherwise it won't give it to you. I haven't been able to figure that one out yet, how to have a graph time versus temperature. This one seems like it's already it's preset, those graphs there. Anyways, that's it. All right,